Hello students, welcome back to chapter 4, Structure of the Atom. In the previous video, we have learned different atomic models proposed by different scientists. And also we have learned about the two subatomic particles, protons and electrons. The third subatomic particle was discovered in the year 1932 by J. Chadwick. And this neutron, they had no charge and its mass was nearly equal to that of a proton. Neutrons are present in the nucleus of all atoms except hydrogen. So neutrons are absent in hydrogen. In general, a neutron is represented as N, small letter n. So as the neutrons are present in the nucleus of an atom like that of protons, the mass of an atom is therefore given by the sum of the masses of protons and neutrons present in the nucleus. So both protons and neutrons are present in the nucleus of an atom. So the mass of an atom is given by the sum of the masses of protons and neutrons present in the nucleus of an atom. Now we can see how the electrons are distributed in different orbits or shells. The distribution of electrons into different orbits of an atom was suggested by Bohr and Bury. There are certain rules for writing the number of electrons in different energy levels or shells. First point, the maximum number of electrons present in a shell is given by the formula 2n square, where n is the orbit number. So the maximum number of electrons present in a shell or an orbit, it can be calculated by using the formula 2n square, where n is the orbit number. For example, K shell. K shell, you know that n is equal to 1. So 2 into 1 square, that's equal to 2 into 1 is equal to 2. And if it is the second orbit or L, 2 into 2 square, that will give you 2 into 4, that's equal to 8. So the first shell, that is K shell, maximum electrons that can be accommodated 2, and in the L shell or the second orbit, maximum electrons accommodated can be 8. Same way, in the third shell can be calculated by substituting n is equal to 3, and in the fourth shell n is equal to 4. We can find out the maximum number of electrons that can be accommodated. The second rule, the maximum number of electrons that can be accommodated in the outermost orbit, that is 8. So in the outermost orbit of an atom, the maximum number of electrons that can be accommodated is 8. Third, electrons are not accommodated in a given shell unless the inner shells are filled. That is, the shells, they have to be filled in the stepwise manner. That means starting from the innermost shell, the shells or the orbits, they have to be filled up. Once the innermost shell is filled, then only we can move on to the next shell. These are the 3 rules for distributing electrons in different orbits or shells. Now, when these electrons are distributed in different orbits or shells, the number of electrons present in the outermost orbit of an atom, they are called as valence electron. So the number of electrons present in the outermost orbit of an atom is called as valence electron. And the number of valence electrons in an atom, that determines the valency of an atom. Then what is valency? Valency is the combining capacity of an atom. So atoms take part in chemical reaction to become stable. That is, if an atom has completely filled outermost orbit, that atom is chemically inactive. They do not take part in chemical reaction. Depending upon the number of electrons in the outermost orbit, the atoms may gain, lose or share electron to become stable. So atoms take part in chemical reaction to become stable, otherwise to gain 8 electrons in the outermost orbit except in the case of hydrogen. And that state is called as the octet state. And what is octet state? The state of attaining 8 electrons in the outermost orbit is called as the octet state. So to attain the octet state, the atoms, they may lose, gain or share electron. That depends on the number of electrons present in the outermost orbit of an atom. For example, if any atom has 7 electrons in the outermost orbit, so to become attain the octet state, that atom needs one more electron. That means there are total 7 electrons. So to obtain 8 electrons, one more electron has to be added. So that atom take part in chemical reaction to gain 1 electron and become the octet state. But if any atom has 1 electron in the outermost orbit, so it will be difficult for an atom. That means it requires more energy to gain 7 electrons and become the octet state, isn't it? So that's why that atom loses that 1 electron in the outermost orbit and then become the octet state. For example, see this table. The given table, in case of sodium, sodium has 11 electrons. That means atomic number of sodium is 11. So 11 electron, it is distributed as maximum 2 electrons in the innermost shell, then the second shell 8 electron and the outermost shell 1 electron. So the electronic configuration of this sodium, it is 2, 8, 1. And that of chlorine, see, in case of chlorine it is 17, 2, 8, 7. Chlorine it is 17, so 2, 8, 7. So when sodium reacts with chlorine, sodium loses 1 electron, then it gets an electronic configuration of 2, 8. And that 1 electron will be received or gained by chlorine and its atomic electronic configuration will come 2, 8, 8. And as 1 electron is lost, sodium becomes positively charged and chlorine gains that 1 electron and it becomes negatively charged. So sodium ion and chloride ion, they are formed. So valency of sodium, then it becomes +1 and that of chlorine, it will be -1. So then what is valency? Valency is the combining capacity of an atom. So the number of electrons or the outermost shell or the valence electron, we can determine the valency of an atom. Is that clear? Now, what is atomic number and atomic mass number? The number of protons present in an atom determines the atomic number of that atom. So we know that the number of electrons and the number of protons present in an atom remains the same. So we can define atomic number like this: the number of protons or the number of electrons present in an atom is called its atomic number. And atomic number is denoted by the letter Z. Capital letter Z denotes atomic number of an element. Now, atomic mass number can be defined as the sum of the total number of protons and neutrons present in the nucleus of an atom. And atomic mass number is denoted by A. Using atomic mass number and atomic number, an element can be represented using its symbol by writing its atomic number to the left bottom and the atomic mass number to the left top. So for example, nitrogen. N is a symbol of nitrogen, atomic number 7 and atomic mass number that is 14. So mass number is 14. So it can be written as N714, whereas 7 is the atomic number and 14 is the mass number. Is that clear? Now, in nature, a number of atoms of some elements, they have been identified which have the same atomic number but different mass number. That means there are certain elements, the atoms of which have same atomic number with different mass number, and they are called as isotopes. That is, isotopes are defined as the atoms of the same element having the same atomic number but different mass numbers. For example, in case of hydrogen atom has 3 atomic species. That is, hydrogen with atomic number 1 at mass number 1. Second one, atomic number 1 but mass number 2. Third one, atomic number 1 and mass number 3. So, you see the difference? All the 3 cases, atomic number remains the same, that is 1. But atomic mass number, that is 1, 2 and 3. So, the atom of the element hydrogen with atomic number 1 and mass number 1 is called protium. Then mass number 2, that is deuterium, and with mass number 3 called as tritium. Is that clear? That means here atomic number remains the same. Means what remains the same? Atomic number means number of protons. In number of protons in all the 3 species remains the same. Mass number, we know that it's the sum of the protons and neutrons. So there is a change in the mass number. That means that there is a change in the number of neutrons. So these isotopes are due to the difference in the number of neutrons. Another example, chlorine. Chlorine, atomic number 17 and atomic mass number 35 and 37. That is, there are 2 isotopes of chlorine. And in case of carbon, one with mass number 12 and the other with mass number 14. So in isotopes, I told you the atomic number remains the same. That means the number of protons and number of electrons remains the same. In an atom, we know that the number of electrons determine the chemical property of an atom. So in all the in all these isotopes, the number of electrons remains the same. Therefore, the chemical property of all these isotopes of the same element remains the same, but there is a difference in their physical property. That is, chemical properties of isotopes are the same, but the physical properties will be different. Now, the mass of an atom of any natural element, that it is taken as the average mass of all the naturally occurring atoms of that element. If an element has no isotopes, then the mass of its atom would be the same as the sum of the protons and neutrons in it. So, in an element, if the element is not having any isotope, then the mass would be the same as that of the sum of the protons and neutrons. But if the element occurs in isotopic forms, then what we had to do is we should know the percentage of each isotopic form, and then the average mass, it has to be calculated. And we can see the applications of these isotopes. Since the chemical properties of all the isotopes of an element, they are the same, normally we are not concerned about taking a mixture. But some isotopes, they have special properties which find them useful in various fields. An isotope of uranium is used as a fuel in nuclear reactors. So, isotope of uranium is used as a fuel. Then isotope of cobalt is used in the treatment of cancer. Then isotope of iodine is used in the treatment of goiter. So these are the three applications of isotopes. So the first one, isotope of uranium is used as a fuel in nuclear reactors, and isotope of cobalt is used in the treatment of cancer, and the third use, isotope of iodine is used in the treatment of goiter. That's all about isotopes. So what are isotopes? Example and its application. Now we can see isobars. So in case of isotopes, we have seen they are the atoms of the same element with the same atomic number but difference in the mass number. But in certain elements, like that of for calcium and argon, here calcium atomic number is 20 and argon atomic number it is 18. The number of electrons in these atoms, they are different. But the mass number of both these elements, that is 40. From this what you understood? There are certain elements, their atomic mass number remains the same, but atomic number is different. So they are the atoms of different elements. The atoms of different elements in which the atomic numbers are different but mass numbers are the same. They are called as isobars. So here the total number of nucleons, that remains the same. What are nucleons? The particles present in the nucleus. Here protons and neutrons. So the total number of protons and neutrons remains the same. And so atoms of different elements with different atomic numbers with the same mass number, they are called isobars. Example, calcium and argon. Calcium atomic number 20, argon atomic number 18. But the mass number of both calcium and argon remains the same, that is 40. So that's all about structure of the atom. Thank you.